In the last video, we talked about how to find the lateral area and the surface area of a prism. You want to wrap a box with paper. Now what if you want to fill the box with packing peanuts? That is volume. So volume is filling something up. The volume of the formula for the volume of a prism is the area of the base, big B, times the height, which is the distance between the bases. So again, we need to use our two-dimensional shapes and our three-dimensional shapes, okay, to create them. So you're going to kind of have to go back and forth. But we don't need quite as much information as we did when we were doing lateral area and surface area. But you do want to kind of go in and do the same thing where you have you would highlight your base to make it stand out because you're using the area of the base. Those big B's, the area of the base, it's not the 6, it's the area of the whole thing. This is your base. Now, the shape of your base is a rectangle. You go back to your formula chart. The area of a rectangle is the base of the rectangle times the height of the rectangle. Well, the base of the rectangle is 6, the height of the rectangle is 2, so the area is 12. And then my height is 4. So the area of the base, the volume of the base is the area of the base times the height. So volume will be the area of the base times the height, which was 4. And so the volume is 48 meters cubed. Now, for a prism like this, you have seen length times width times height. So if you remember that, you can always go back to that if you have a rectangular prism. If it's something other than a rectangular prism, then you're going to have to use a different, you can't use that formula. Okay, that length times width times height only works for a rectangular prism. The reason why is because length times width is the area of the rectangle times the height. Okay, we did this trapezoidal prism in the last lesson with lateral area and surface area. We do still need the area of the base. And then we need the distance between the bases. When you see that the question is asking for volume, write down the formula so that you know what you need to do. Well, B is the area of the base. This is my base. It is a trapezoid, so the area of a trapezoid is 1/2. The bases, this is 18, is 18 plus 23 times the height of the trapezoid, that's 12. You have to keep straight what's the height of the trapezoid versus what's the height of the prism. So you get that that is 246. That's what we got the other day. So volume is equal to the area of the base, 246, times the height. Now this time you want the distance between. Imagine pushing that yellow trapezoid back into jello. How much space is it going to take up if I push it back? So that's the direction you're going to push it. With this one, I would be pushing that yellow rectangle up 4. That's why we use the 4. So it's 246 times 15. So the volume of this prism is 3,690, and that's cubic feet, or feet cubed. Okay. I see that I need the volume of, and this is a prism, so I go and I look it up on my formula chart. The volume of a prism is the area of the base times the height. So what is the base? Anytime you have a shape other than a rectangle, that is going to be your base. You're looking for what is congruent and parallel, the two that are congruent and parallel. Now I have these two triangles, they're the same size and they are parallel to each other. So I need the area of that triangle, that's my B. The area of that triangle, the area of a triangle is 1/2 the base of the triangle times the height of the triangle. So that would be 1/2 the base, which is 12, times the height of the triangle, which is 5. So the area of the base is 1/2 of 12 times 5, which is 30. So now I have that the volume is equal to the area of the base, which is 30, times the height, which is the distance between the bases. This one's different, right? This H right here and this H right here are not the same. And that's 14. And 30 times 14 is 420, and that is meters cubed. Okay, same thing with our, this is a hexagonal prism. So we go here, and this is our base, right? That's our big B. And then our H, that's our H that we need for volume. So volume is equal to the area of the base times the height. Let's go find our base real quick. The area of the base, this is a regular hexagon. It's 1/2 AP, so it's 6.93 times the 1/2 AP, right? So that's the perimeter. So it would be 8 plus 8 plus 8 plus 8 plus 8 plus 8. 8 times 6 is 48. So the area of the base, 1/2 times 6.93 times 48 is equal to 166.32. Now we have the area of a base. We have our height, which is our distance between our bases. So the area of the base is 166.32. The height is 19. You multiply those two together and you get 3,160.08, and that would be cubic feet. Feet cubed. Okay, so that is the volume of a prism. You find the area of the base. So you take a break from the three-dimensional. You go in and you find your two-dimensional shape for just a minute. You focus on your yellow shape, and then you multiply it by the height of the shape. Like now you're going to push this shape into the dirt or whatever it is, and that's the space that's going to be cleared out. Okay, now let's look at the volume of a cylinder. So the volume of a cylinder, anything round is nice because it has its own formula that all we have to do is plug it in. It is still area of the base times the height, but on your formula chart you'll see that it's pi r squared h because B is the base, which is a circle, which the area of a circle is pi r squared. So if I want the volume of the cylinder below, this is my radius, and this is my height. So volume is equal to pi r squared h. So volume, that's what I'm trying to find, is equal to pi r squared, so 3 squared, times the height, which is 6. And again, if you want, you can keep it and you can just do 9 times 6 is 54, and that's 54 pi. I won't ever ask for you to leave your answers exact like that, but I just want you to know that it exists. And so then my volume, if I type in 54 times pi, and you can go straight from here to here. You don't even have to do the 54 pi if you don't want to. That's 169.6, and that would be meters cubed. Volume is cubed, meter times meter times meter. So the next question says, Madison made a cylindrical vase for her art project. That's important. What shape it is important because we're going to be mixing them all up later on. If the vase has a volume of 454 cubic inches and a diameter of 8 inches, what is the height? So I'm asking for h. I always like to draw a picture, so a cylinder looks like this. It has a volume of 454. So I know I'm talking about volume, so I'm going to go to my formula chart, and I'm going to find out that the volume of a cylinder is pi r squared h. So then what I have to do is I have to plug in the pieces that I know. I know V, I know the volume, so I plug it in. 454 is equal to, pi is pi, r squared. I need the radius. Well, the diameter is 8, which means that the radius has to be 4. So 4 squared, and then h is what you're trying to find, so you just leave h. So let's go ahead and do the math we can do. I can do that math right there. So 454 is equal to, well, pi times 4 squared is 50.265h. I just keep 2 or 3 decimal places so that it'll be more exact. Then divide both sides by 50.265. And you get that 454 divided by 50.265 is 9. So your height is 9. Now, ice cream is sold in 2 different containers. The first container is a cylinder. As soon as I read the word cylinder, I'm going to draw a cylinder with a radius of 4.5. Let's label it as we go, and a height of 11. The other container is a rectangular prism. It has a base of 8, a width of 5, and a height of 9. Which is the best relationship, which best describes the relationship between the two containers? Are their volumes equal? Are their volumes, can you even tell anything about their volumes? Is the prism hold more, or does the cylinder hold more? That's what we want to find out. So we're just going to do this real quick. So the volume of a cylinder is pi r squared h, so pi times 4.5 squared times 11. You type all that in on your calculator just like that, and you get that the volume of the cylinder is 699.8 cubic inches of ice cream. What could be better? And then the volume of the prism would be the area of the base times the height, which the base is a rectangle. You could also just instantly go to length times width times height if you want. Length times width times height. So you would do 8 times 5 times 9, and you get 360 inches cubed. So obviously the cylinder is bigger, and so that's what your answer would be, that the cylinder is bigger. So as always, go back to your formulas, write them down, take the time to write them down, substitute in what you know, and then find your missing piece.